Okay, so here we are, 5.3b in college algebra, still dealing with exponential and logarithmic functions, and I'm example number 5, investment. And we've got if $10,000 is invested for T years at 10%, compounded annually, the future value is given by, and of course they give you a formula. 10,000 is the amount you invested, and 1.10, the 1. This is actually 110%, so we want the 100% of what we put in, and then the 10% is the interest rate. So that's where the 1.10 came from. It's 110% made into a decimal. And then, we have an exponent of t. Okay, so again, we have an exponent of t, so we're going to use logarithms. And then it says underneath the formula, in how many years will the investment grow to 45,950? So we're going to put 45,950 there equals 10,000, 1.10t. Okay, so we've got a lot of stuff there. So what we're going to do again, because t is the exponent, we're going to put this in logarithmic form in just a minute, but we're going to first of all get rid of that by dividing both sides by 10,000 and dividing this by 10,000. And those go away. And 45,950 is 4.5950 equals 1.10 t. Okay, so we simplified it as much as we can. So now we have is 3 parts. So therefore we can change this to logarithmic form. And we have t equals log, that's my base, yuck, 4.5950. Okay, we cannot do anything with a base of 1.10. So therefore, we're going to have to use our change of base formula in order to find t. So this, in our change of base formula, is going to be log 4.5950 over log 1.10. Okay, so you put that in your calculator, divide those two, and you get a number, I think it's exactly 16. So 16 years, that 10,000 will turn into 45,950. That's, of course, if you had 10% interest, which is a very rare situation. So, unless you did pretty well with your stocks, but then that isn't compounded annually necessarily. Okay, anyway, next section, solving exponential equations using logarithmic problems. Okay, what we did before is we solved exponential equation using logarithmic forms. Now we're going to solve them using logarithmic properties. And top of page 349 in green gives us the steps to do it with. So let's take one and follow those steps. So I know I'm dealing with logarithms because I have an x in the as an exponent. Okay, so first step, rewrite the equation with a base raised to a power on one side. So that's already done because we have a base raised to a power here on one side. There's nothing else added or subtracted or anything. It's just that. So that brings us to 2. Take the logarithm, base e or 10, of both sides of the equation. So what we're going to do is we're going to take the log of 4096, and that equals the log of 8 of 2x. Okay, next step. Use the logarithmic property to remove the variable from the exponent. Okay, remember that? If we have an exponent, we have log 4096 equals, we put that in front. Okay. Once we do that, we are going to divide both sides by this 2 and this, leaving my x by itself. So I'm going to put 2 log 8. So remember, these two are not connected. I can divide by 2 and divide by log of 8 and leave the x there. So now I take the log of this and the log of 8, multiply it by 2, and divide, and I get x equals 2 when I do that. All right, let's do b. B's got a little bit more complicated exponent there. We have 6. But if you follow the rule, everything works the exact same way. It's really nothing too terribly confusing. Okay, so first of all, we isolate the exponential expression on one side. So we're going to divide by 6 to get rid of that. And we've got that. Okay, doesn't look too bad. Now we're going to take either the natural log or the logarithm of both sides. This particular one, they took the natural logarithm, which again, nothing's really weird. You just take the natural logarithm instead of the common logarithm. And we take that to both sides, and that's one thing nice. Just like you divide both sides by 6, we can take the ln of both sides, and it doesn't change the value of anything. Now we're going to put that, and this is the nice thing about doing this. Okay, let me explain real quick why it's so nice to take the ln or the log. Because it forces this out of the exponent position and puts it down here. Okay, and then we can get the ln's together. So we divide by ln 4, divide by ln 4, and it gets rid of that and gives me 3x minus 2 equals ln of 20 over ln of 4. Okay, so see what happened there by just taking the ln. It allows me to get my exponent from an exponent down here in front of the ln. So now I can add 2 to both sides, and those go away. And then I can divide both sides by 3. Okay, and I get kind of a hairy thing here, but it's really pretty easy to do. All I do is take the ln of 20 over the ln of 4, get that answer, add 2, divide it by 3, and I end up with a number close to 1.387. And if I wanted to, it doesn't really matter. Instead of taking the ln of both sides, I could have taken the log of both sides. The only difference is when you take the log of 20 over the log of 4, you're using the log button instead of the ln button. It's the only difference. It's just which button you push, the ln or the log. The answer is going to be the exact same regardless. Okay? All right, so example number 7, we are taking 4 log base 3 x equals negative 8. All right, it says by converting to exponential form and then verify the solution graphically. Okay, so again, graphically, go ahead and use your calculator and mess around with that in part B there, or figures A and B there. So first of all, we're going to isolate the logarithm. Okay, so we're going to divide both sides by 4. Almost always, well, it is always what you do first. You isolate either the exponent or the logarithm. Okay, so now that we're in that form, now we're going to change my logarithm to exponential form. Okay, and this here means that I'm going to square my 3, and the negative means I'm not going to be 3 over 1, I'm going to be 1 over 3 squared, which is 1 over 9 equals x, and that's it. Okay, so let's look at example 8, and we're going to start solving some logarithmic equations. So we've got 6 plus 3 ln of x equals 12. So we're solving for x here. Okay, so we solved the equation for ln of x, so we're trying to get ln of x by itself. So 3 ln of x equals 6. Subtract 6 from both sides. Now we're going to divide both sides by 3. Gives me 2. So ln of x equals 2. So if I want to change this back to exponential form, okay, I get e squared equals x. So I hit my, well, I found x. I don't have to put that in numerical form, but you could just square e and get a number. But anyway, that's how the book ends up leaving that, bringing us to example number 9. And number 9 is another logarithmic equation we're going to solve for. And again, we're solving for x. And all of this just takes practice on which form to use and how to do everything. But first of all, again, we're going to get my logarithms on the same side. Okay? So, I'm going to move this over to the other side. Okay, so I moved it the other side. Because I have a minus here, my quotient property of logarithms says that I can rewrite this as ln of x plus 4 over x. And the nice thing about doing that is it changed it from 2 logs to 1 log. So that makes it easier to work with. That's my goal, is to get it to be 1 logarithm. Because once I get it to 1 logarithm, I can change it to exponential form. Okay, so I'm going to change this to exponential form. Nope, use my e because there's an e right there's my base. So my e is 3 equals x plus 4 over x. Okay, so I'm still solving for x here. So I'm going to multiply both sides by x. Now I'm going to subtract x from both sides. Oops. Probably help if I actually subtract it from both sides, huh? Now I'm going to factor out an x from this side. Okay. Now I'm going to divide both sides by e cubed minus 1. Cancels that. So there's my x. Okay, now I just have to take e cubed minus 1 and take 4 divided by whatever e cubed minus 1 is, and I get a number similar to 0.21. Okay, so there are some examples, and we'll do some word problems in the next video. So that is 5.3 B as in boy.